All right, I want to address a couple of questions that I have received via email about two of the homework problems from Chapter 7, specifically number 9 and number 11. Before I do that, I want to look at this section in the PowerPoint slides where you're given the formulas for how to calculate, given a polarized wave, and in this particular example, this is a circularly polarized wave. Given this polarized wave, you're given an example of how to calculate the magnitude of the electric field. And so notice that it's basically the square root of the x component of the field and the y component of the field. And notice that it can be a function of time, just depending on the type of polarization. So notice what was substituted in for E subscript x was a cosine omega t minus kz, and for EY was a sine omega t minus kz. And so when that's substituted in and both of these terms are squared, we can factor out the a squared, giving us a, and then the cosine squared plus the sine squared is just 1. So basically the magnitude here is a. So now let's go and look at the two homework problems. Sorry, this is not the right one. Let me look first. We'll look at number 9. So here's problem number 9. And you can see that it's almost exactly as the same problem. The same problem is traveling in a different direction. So that's really the only difference here. So what should happen when the modulus is calculated is this first term should be a squared cosine squared omega t plus kz. And the second term should be a squared sine squared omega t plus kz. Meaning that just like in the PowerPoint slide, we would factor out an a squared, and what would remain under the radical, it would not be a squared plus a squared. It's a squared cos squared plus a squared sine squared. Meaning when the calculation is done, basically you end up with a, not a times the square root of 2. So there is an error in this problem because they did not plug in the cosine and the sine. So a then would actually not be the square root of 2. A would be 2. Um, and so the rest of this problem I think is fairly straightforward. We can talk a little bit about the placement of the negative sign as a sign here for the y hat component. So we're told it's traveling in the minus z hat direction. We're told it is right-hand circularly polarized, but remember that things go in the direction of x, y, z, and it's traveling in the minus z direction. So if the x component, if the x vector component has a positive sign and the y vector component has a positive sign, then basically the direction of travel would be in the positive z direction because it goes x, y, z. So in this case, the x component has a positive sign and the y component has a negative sign, meaning you're negating the cross product. So it's x cross y would be z, but then because you have this minus sign, you would pick up a minus z hat. The same would be true if the negative sign were associated with the x component and the positive sign associated with the y component. So it's just because your travel is known to be in the minus z hat direction. Now in their explanation, they tell you to use the right hand rule and place your right hand in the minus z hat direction, rotate clockwise, and then that'll tell you if you're going from x to negative y or x to positive y, and that is perfectly fine as well. But if you're one of those people who has trouble implementing the right hand rule, you can just remember that it goes positive x, positive y, positive z. So if you have negative z, when you have right hand, so if you have negative z, then it would be positive x, and it would have to be a negative y. The rest of this I think is pretty straightforward. Now let's look at problem number 11, which I believe the solutions manual actually has correct. So if you look here, here is our cosine and sine. And here is the calculation of the modulus or the magnitude of E. You will notice that we have EX squared plus EY squared. EX squared is 30, and the cosine function has to be included. EY squared is 30, and the sine function has to be included. And so what you'll end up with here then is 30 squared times cos squared plus sine squared, which means when you take the square root of that, you'll just get 30, and these cos and sine terms will become 1. So this one is actually done correctly as far as calculating the modulus or the amplitude, and problem number 9 is done incorrectly. So hopefully that resolves any questions. I think I posted something about this previously. I think maybe I fell into exactly the same trap that your author did. So my original comments on this problem may have been incorrect. I need to pull up that email and see what I said. But anyway, just wanted to post this short video to look at these two problems, compare why one says one thing and the other says another thing.